Okay, so this is video 2. So what is the actual pressure equation? Well, it's just what we did before with the ratio but in letters. So pressure is small p, and it's equal to large F for force divided by large A for area. What's the unit? Well, you could work it out from there as newtons per metre squared, but we are actually going to use something a bit easier that has been decided upon to celebrate a famous scientist, and we're going to call it the Pascal. Now here's an example. A builder was using a mallet to drive some marker pegs into some hard ground. Below are two pegs. The mallet exerts a force of 300 newtons onto the pegs. Which one will penetrate the ground the furthest? So, the area at the bottom of this one is, let's say, 0.01 meters squared. This one is 0.001 meters squared. So all you have to do is just work out pressure equals force over area for each one. So the first one will be 300 divided by 0.01. That gives you 300,000 pascals. Oh, sorry, 30,000. And the next one, you'll find that it's going to be one extra zero. So which one will penetrate the ground furthest? Well, it's going to be this one here, because it's got the greatest pressure. Here we've got an idea where we can actually lift up cars using a small piston to drive a large piston. Now in liquids, pressure is transferred along in all directions with the same size pressure. So the pressure is the same everywhere in a liquid. So if you push down on this one here, it's got a certain area A1. So that force 1 divided by area A1 will give you some sort of pressure. Now that pressure is a constant. So on this side, we're now going to have force 2 over area 2 giving the same pressure. So let's say you put in some values and said, okay, let's put in a 10 Newton force divided by 1 meter squared. That equals 10, so the pressure is 10. So on this side, if our area is now 2 meters squared, so we doubled it, the force now is doubled to 20 to get the same value of pressure. So we've doubled our force to help us lift things easier. So if you have an area that is 100 times larger, we have 100 times the force. Hence why you can lift things like cars. The same effect is actually applied on your brakes. Okay, so there's a small piston by your foot pedal, and that goes to a larger piston on the brake to increase the pressure. So same thing, pressure from your pedal is going to be equal to the pressure at the brake, okay, because the pressure is transferred through. So that's going to be force at the pedal divided by area of the pedal is equal to force of the brake divided by area of the brake. So if the area of this brake is much larger, then the force will be much larger to get the same ratio. This is what this just talks about here.